Hello everyone, and welcome back to the Fluctus Channel. Massive aircraft like the C-17 Globemaster III and C-5 Galaxy rank among the largest military transport planes ever built. These giants operate with precision, thanks to constant maintenance and meticulous servicing. But when one of these colossal machines goes down, the consequences are extraordinary. Crashed, damaged, and disabled aircraft recovery, or CDDAR, teams were first established by the United States military in 1942.
Questions, concerns, comments?
If we lose a bag, are we just stopping everything?
Their importance became evident during the Berlin airlift of 1948 to 1949, when they were instrumental in maintaining the flow of air operations despite the loss of 17 American and 8 British aircraft. The CDDAR system is designed to recover and restore damaged or immobilized aircraft to operational status as quickly as possible. This demanding task requires highly trained specialists, detailed recovery procedures, and advanced recovery equipment. In each operation, teams assess the aircraft, secure it, lift it safely, and transport it to a designated recovery site, minimizing the loss of valuable assets. Often working in harsh or even hostile environments, CDDAR personnel play a vital role in sustaining the momentum of military air campaigns. CDDAR towing operations entail a variety of platforms, each with its own set of advantages and disadvantages. Towing is a mission-critical task from the front line to the forward operating base, or FOB. One method required is called frontline recovery. Under fire, on-field recovery personnel clear crashed aircraft. These towing operations, which use specialized vehicles such as the M984 Wrecker, are high-risk and time-sensitive. During base operations, CDDAR ground support equipment is used at an airbase. Tow tractors, tugs, and bar receiver systems transport damaged aircraft to hangars or repair locations. Then there is external transport, which includes larger assets, such as the C-5M Super Galaxy for hauling aircraft fuselages or major components. Specialized equipment aids recovery efforts in CDDAR operations. Crash bags, also known as lift bags, are extremely important. The 25-ton lifting inflatable equipment are used to elevate the wreckage securely while limiting further harm. Controllable air inlets enable precise, progressive lift, which reduces strain. Cranes, particularly the Deployable Universal Combat Earth Mover, or DUCE. M88A2 Hercules and M984 Wrecker, with their high-capacity winches, are critical heavy lifters in CDDAR. Other tools include dolly sets for supporting landing gear, cable cutters for severing recalcitrant parts, and specialized airframe jacks. These exercises prepare the CDDAR teams for actual aircraft recovery operations, such as the one in Afghanistan. FOB Schenck was a key U.S. FOB operating as a critical operational hub in Logar Province, eastern Afghanistan. On January 23, 2012, the 17 Airlift Squadron's C-17 Globemaster III, tail number 000173, encountered a severe landing disaster. Due to unfavorable weather circumstances, the C-17, a 4-engine military transport aircraft with a cargo capacity of 170,900 pounds, overshot the runway, seriously damaging the aircraft. The incident resulted in a temporary suspension of air operations, and there was no loss of life. However, the aircraft was declared unrecoverable on the scene due to substantial structural damage. Later, that assessment was changed. Experts found that the damage to the downed C-17 at FOB Schenck, while significant, was surmountable. The CDDAR program moved its focus to recovery and restoring the plane for future use. To minimize further damage, crash bags and hydraulic jacks were utilized to stabilize and lift the aircraft. Crews then worked carefully on-site to remedy minor structural faults while removing, documenting, and prepping damaged components for departure. Larger parts, such as engines and avionics systems, were returned to the United States for extensive repairs. The crucial frame was left intact and carefully transferred to a secure location using towing vehicles, where long-term repairs begun, resurrecting this vital aviation asset for future operations. The U.S. Navy continues its arduous task of battling the ferocious waves to safeguard the nation. However, things get more challenging when the mission environment shifts from the ocean surface to the ocean floor. Deep ocean salvage operations are the most intense operations that one would ever undertake. Such operations have become mandatory due to a multitude of reasons. Two such noticeable incidents occurred involving an FA-18 Super Hornet and a P-8 Poseidon aircraft in 2015 and 2023. The FA-18 crashed just after takeoff from the aircraft carrier USS Theodore Roosevelt due to an engine failure. The pilot and the weapons system officer were safely ejected, and the aircraft sank to the bottom of the Persian Gulf. Navy divers and explosive ordnance disposal technicians joined hands in salvaging the fighter, and the impetus behind the recovery was to analyze what actually brought down the aircraft. Salvaging the fighter was a task of its own, as the Navy divers had to reach a depth of 190 feet. Unlike the recovery of the FA-18, the recovery process involved with the P-8 Poseidon was strenuous due to its larger size. The aircraft was operating under Patrol Squadron 4 of the U.S. Navy as a long-range anti-submarine warfare and maritime patrol aircraft. The Poseidon is based on the Boeing 737NG airframe and carries torpedoes, harpoon missiles, naval mines, and sonobuoys in its internal and external hardpoints. The aircraft overshot the runway during landing at the Marine Corps Airfield in Kaneohe Bay, Hawaii. The highly sensitive environment at the bay added an extra layer of complexity to the recovery mission. Navy divers conducted an underwater hydrographic survey prior to the recovery mission to assess the conditions on the bay floor. During the assessment, it was identified that the aircraft was resting on the coral reef at 2 points while the fuselage was floating in the water. The aircraft was then anchored to avoid further movement that could possibly damage reefs. Protecting the highly sensitive marine environment and ensuring the safety of the salvage crew were of the utmost priority. Additionally, every effort was made to recover the aircraft with minimal damage to preserve its operational capabilities. Inflatable salvage roller bags were placed beneath the fuselage. These cylindrical float bags lifted the aircraft and allowed it to roll smoothly off the water towards the runway. Perhaps an even more technical and difficult recovery operation is the recovery of ships lost at sea. One such ship recovered was the CSS Georgia. It was an ironclad gunboat built in 1862 and operated by the Confederate forces. This ship replaced wooden ships due to its ability to withstand heavy fire. Due to the extraordinary weight of the ship and the strong current at its intended operational theater, the Savannah River, the boat became unnavigable. Thus, it was used as a floating battery. Furthermore, due to its larger size, it acted as a hurdle for crossing the river. With the outbreak of the Civil War in America, Confederate forces utilized this boat by scuttling it along the Savannah River in an attempt to avert the movement of Union forces into Savannah. Since then, the ship has remained submerged for more than a century until certain parts were recovered in 1986. Advancements in novel sonar technologies assisted the archaeologists in obtaining a clear picture of the site's topography. They have used single and multi-beam sonars, along with novel computer models, to map the wreckage. During the efforts of the U.S. Army Corps to deepen the Savannah River, the wreckage site was at risk. Due to its high historical value, the site was handed over to the archaeologists for excavation, making it the largest archaeological site in the entire U.S. The close proximity of the site to a busy container port made recovery missions more challenging. Underwater archaeologists and Navy divers dove to the bottom of the Savannah River to identify wreckage. During the recovery efforts, divers had to deal with high river currents and limited visibility in turbid water. Due to these intricacies, divers are tracked by high-tech tracking systems, such as the ultra-short baseline diver tracking system or the USBL system. The positions received from the USBL transponders of the divers were correlated with the geographic information system data of the site to increase their navigation efficiency. The identified parts of the ship were strapped into a crane on a barge. A few cannons were identified and recovered during the early recovery missions. The largest parts recovered were the casemates of the ship, which were the armored structures that protected the ship from enemy fire. Nearly 30,000 parts were recovered during the entire mission. Among them, around 13,000 parts were sent to a conservation research laboratory for conservation, and the non-conservable parts were reburied in the Savannah River itself. While these recovery missions create a tangible connection to the past, they also leave room to expand impacted natural resources as crucial arteries in the economy. On the other hand, salvage and recovery missions may stand as the last resort for unfolding the mysteries of air crashes. In achieving these goals, the unsurpassed accuracy and efficiency offered by state-of-the-art acoustic and imaging equipment are truly commendable. In the end, recovery operations, whether on land or beneath the sea, reveal the extraordinary skill and dedication of those who refuse to leave any asset or history behind. From the CDDAR teams that bring crippled aircraft back to service, to Navy divers and archaeologists recovering wrecks lost for decades, each mission reflects precision, teamwork, and courage under extreme conditions. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.